If not, please grab one. Unit 7. Today, going to be talking more on angles, triangles, and prisms. Okay, so a lot on measuring angles. We'll talk about how to do that here throughout the first few units or sections. Prisms, surface area, and volume to end the unit. So really switching gears from what we have been doing. Notice there are 17 lessons. Probably going to do a quiz after 8 or 9, depending on where that falls, about halfway through. And then at the end, we will quiz and test like we always have. So the first lesson, okay, visualizing angles. So we're just going to talk about angles here today, probably the next 3 days, and talk about how to measure them here more exact as we go. So I'd like you to answer question 1 and 2. In your opinion, which one is bigger? And then identify an obtuse angle in the diagram on the bottom. So go ahead and answer those two. I'll give you about 30 seconds to do so. Ryer.
They're both the same.
Both the same.
And then for number 2.
Okay, but hold on. We'll just do one first. Both the same. Now it looks like B is bigger, right?
Yeah.
Just because it looks like a bigger angle. Now we could double check it, because if the angle is the same, that's all that matters. So I just traced it on there. And if you match it up to B, you can see that it is the exact same angle. Just because the lines are longer does not mean the angle is bigger. They're both the same degrees. Okay, those lines could go on forever. It's not going to change the degrees of the angle because that is measured here. So which angle is bigger? Ryer's right on that they're the same. Next one, identify an obtuse angle in the diagram. So we better know what an obtuse angle is. Jada, what's an obtuse angle?
Greater than 90 degrees.
Obtuse means it is greater than 90 degrees. So we might as well look at some other terms. If you ever see acute angle, what does acute mean, Parker? Less than 90 degrees. We will have a right angle. What does right angle mean? 90 degrees, exactly. And this might be a new one for you. A straight angle. 180, like a straight line. So I would write those down, so if you ever see those terms, you know what they mean. So those are the 4 ways to classify an angle by degrees. So knowing that, we're looking for an obtuse angle, so we know it has to be over 90 degrees. Jackson.
DAB.
Angle. DAB. Angle is usually going to be with 3 letters. DAB would be this whole angle here. How many degrees is DAB? Cruz. 110. 60 plus 50. I could have also named the angle BAD, opposite order, but the middle one has to be A. So those would be the 2 possibilities. Anything other than that will not work. But 3 letters when you name an angle. Sometimes you'll see something that looks like this, and that just means what is the measure of that angle, if you ever see a little m, which you already answered was 110. All right, question 2. Dieterle, would you read that one, please?
Trace one common copy of every different pattern block. Each block contains either 1 or 2 angles with different degree measures. Which blocks have only 1 unique angle, which have 2?
All right, so I'm just going to grab a few blocks here. And you're going to kind of trace them, sketch them. Here will be the first one. So go ahead and trace that or sketch it. You're going to have 4 different shapes there, so plan accordingly when you put this one on there. Does this one have 1 angle or 2 unique angles inside of it? So that's saying, are they all the same, or are they all going to be different? They're all the same. They all should have the same degree. So write down next to that there would be 1 angle associated here. They're all the same. What kind of shape is this one? That is a trapezoid. How many different angles do you see on this guy? 2. Acute angle on the bottom, obtuse angle on the top. This one would have 2 different angles in it. So that's a trapezoid would have 2. Another 4-sided figure. Cruz? 1. Square would have 1 angle. They're all the same. Last one. What kind of shape is that?
Stop sign.
Nope. Huh? Hexagon. Octagon was stop sign. That'd be 8. This is a hexagon, has 6. Hexagon. How many different angles? 1. They are all the same.
How are we supposed to know that?
Well, they have another one down here. Okay. All right, question 2. Leroy, would you read it, please?
If you trace these copies of a hexagon so that one vertex from each hexagon touches the same point as shown, they fit together without any gaps or overlaps. Use this to figure out the degree measure of the angle inside the hexagon pattern block.
Okay. So I'm going to show you that they fit together just like the diagram there. Okay. The question is, how many then is each degrees? Well, if you look at the center, which they're kind of showing you in this diagram, a complete circle is how many degrees?
360.
Complete circle is 360. How many angles make up the 360 here? 3. So 360 divided by 3 would tell us the angle of each hexagon. 120 degrees in the hexagon. 120 degrees in the hexagon. Okay. Next shape. This one you probably already know. We're going to do the square next. Look at how many it takes to close the figure down here. 4. So now I have 360 divided by 4. That means each angle is 90, which we probably knew on a square to begin with. Next one. How many triangles do you think it'll take to fill the circle?
6. 4. 6.
There's 3.
9.
6.
Woo!
Okay, notice the shape it makes. Makes a hexagon.
No.
Divided by
So 360 divided by, how many triangles did it take? 6. 360 divided by 6? 60. 60, and if you put that on top of a
Whoa.
hexagon, it should be the exact same.
There should only be
All right, now this one's a little different. Okay, I'm going to use this one since you told me how many degrees it made, right? Each one of these is what? 60. So let's look at the bottom angle. So these make a straight line or a straight angle. Remember how many degrees a straight angle is? 180. You just told me that on the previous page. Straight line, 180. So if this is 60 and this is 60, what is this? 60. Has to add up to 180. And if you put a triangle on there, you'll see that it's the exact same angle. Okay? So this angle on the trapezoid would be 60. Now let's look at the top. Told me it was two different angles, right? So this is 60. What's this if it makes 180 at the top, makes a straight line at the top? 60 plus what?
90.
60 plus what makes 180? 120. So this one is 120. This one is 60. Okay, now we found all the angles that we said existed inside of a trapezoid. Questions on that? All right. The Are You Ready? Lauren, would you read the Are You Ready, please?
We saw that it's possible to fit 3 copies of a regular hexagon snugly around a point. Each interior angle of the regular pentagon measures 108 degrees. Is it possible to fit copies of regular pentagon snugly around the point? If yes, how many copies does it take? If not, why not?
All right, so now we're talking pentagon. How many sides on a pentagon? 5. Well, let's check it. We know it's got to equal 360. So let's try a number. How many pentagons would it take to make a perfect circle?
6.
Can't do halves.
3.
3. All right, let's see if we get 360. 8 times 3 is 24. 3 times 0 plus 2, you get 324. So 3 is not enough. 4. 32.
6.
3. 4.
6.
Do I get 360? No, so it'd be silly to try higher. You're going to get more than 360. If 4 is too much, 6 certainly is.
5.
So will it fit together nicely? No. It will not. There's no way to get 360 out of full pentagons. All right, next question. I would like you to guess what the angle is, and then we're going to use these shapes to try to help us out. Guess what those angles are.
Okay.
A, B, and C. Keep in mind, is it more than 90? Is it less than 90? Those hints. Jackson, you got the first one? Okay, I want to know how many degrees or the directions.
It's 160.
160. Okay, anybody got anything different? 160. What do you got?
107.
107. Okay, using all those angles that we talked about for number 3, not sure how you got 7, because none of them ended in 7 that we talked about. So that's not really an option.
I have 108.
108. Did any of them end in 8 that we talked about?
Yeah. Well, kind of.
Okay, the pentagon did.
And it's
Yep.
right there. I have 135.
135. All right, let's check. This was 135 we said, right? Or no, this was 120.
We said. I thought it was 108. Yeah, 120.
This was 120. We did it on number 2 on the previous page. Let's see how close this is.
Oh.
That looks like it's exactly
I was close.
That's like exactly.
That's what I was going to say.
120.
I was
Okay, so A here is 120 degrees.
I got that on the dot.
Okay, now B. Look at where B's at. We know it's more than 120.
Okay, I think I know.
Let's put 2 together. Okay, that's a little too much. So we know it's less than 240 because those are two 120s. Let's try 90 with it.
No way. No, 110.
That looks like it's right on.
I said 1.
So this was 120. This was 90. That's a total of 210.
That's too much. 210?
On the dot.
210. Sure.
180.
180. Let's check. These two are 90.
I say 180 too.
So it looks like it makes a nice straight line, straight angle. Trey, turn around, please. 180 is correct.
Yeah.
180
At 1,000.
is correct. Number 2, Dieterle.
If an angle has a measure of 180, then its size from a straight line, an angle that forms at a straight line is called a straight angle. Find as many different combinations of patterned blocks as you can that make a straight angle.
All right, so we need to make a straight line. So we'll just kind of go through a couple here. Hexagon and a triangle. 120 and 60 make a straight line. We talked about 3 triangles. You can see how that makes a straight line up there. Can do a square and a square.
Perfect.
Straight line. Can do a trapezoid and a triangle makes a straight line. If you want a straight line up top, you would need 2 triangles. Now it makes a nice straight line. Okay, so it's up to you. We just did a lot of different options there. They have to add up to 180. That is the key. Have to add up to 180. All right, question 4. Lear, do you got a question?
So when we get like a question on our homework, like how do we figure it out, like without our like the building blocks thing?
Well, you know that these are 60. I know that another one would be another 60. And another one would be another 60. And I know that 3 60s make 180. So using all the angles that you wrote down, if it would ask you for the shape, you should know what the angles are without these, right? You have to add up to 180.
Did you see that one slide?
Trey,
You go back, I didn't write them down.
you can get them from somebody at the end. I told you to write them down.
I know it's supposed to write.
All right, question 4. Jackson Thornton.
Oh, yay. I get to read? Tyler and Priya were both measuring angles, TUS. You want me to read the...
Yes.
Priya thinks the angle measures 40 degrees. Tyler thinks the angle measures 140 degrees. Do you agree with either of them? Explain your reason.
Okay, so this, you can put your hand down right now, Matthew. Tool is used to measure angles. It is called a protractor. Okay, write that down. Trey, it is a protractor. Not to be confused with a compass that we used when we drew circles. Sometimes we get that confused. One's to use to draw circles. This one is used to measure angles. Now this is going to be the same thing you see here. See that the angles match up perfectly. I'm going to talk a little bit about how to measure with these. We're not going to do that today. They got it nicely drawn here for us. But here's what I want to tell you. Anytime you start, you're going to start by drawing a line. Pretty simple. Now you see little crosshairs on here. Hopefully. See those crosshairs? That is where you will always put this dot on the crosshairs. Not on the bottom, not on the top, right on those crosshairs. And then the importance of this line needs to be right at 0 degrees. Now, does my line go to the right or to the left?
Right.
Goes to the right. That means I'm going to start at 0, and I'm going to use these small numbers. See the small numbers? Notice the top has bigger numbers. So I'm going to make one here at right there, and we'll talk about what degrees that is here in a second. And I'm going to connect them. Okay. Now, to measure that angle, is that a obtuse or acute angle? Acute. Keep that in mind when you tell me what the answer is here. So I see a 150 and I see a 30. So how many degrees is my angle here? 30. You told me it had to be less than 90. So how do I know it's 30? Well, I can see it's less than 90. My line is drawn to the right, so I am going to start at 0 to the right and use these small numbers. So this is how you would answer how many degrees that is. You would say 30 degrees. Okay, if you ever have one to the left, again, I'm going to draw a line, put a dot. I'm going to draw a little bigger angle here. Now, is that more than 90 or less? More than 90. Keep that in mind when you give me my answer. I'm going to put the protractor on there. Now my line goes to the left. So I'm starting at 0 over here. My numbers are going to get bigger. That's why there's two sets of numbers on here. One can go each direction. Your angles aren't always going to face the same way. So my line goes to the left. I'm starting at 0. So how many degrees would you say this line is?
110.
110. How come it's not 70?
Because it has to be bigger than 90.
You said it's obtuse. You said it had to be bigger than 90. So this one would be 110 degrees. Okay, questions on that? All right, so I want you to answer then the one that Jackson read. It says, do you agree with Priya or Tyler? And be ready to explain why. I'll give you about a minute. Priya or Tyler, and why? Abby, what do you think? Why?
Because it's less than 90.
Yeah, it's less than 90. Or you could have said my angle goes to the left, my line goes to the left, so I got to start at 0 on the left. This one is 40 degrees. Any questions on that? Again, in a couple lessons, we are going to be drawing our own. This is just kind of a taste of what a protractor is and how it is used. Take a look at the summary. Again, some terms. Right angle we talked about. Right angles are always 90 degrees. Straight angle we talked about, always 180. We talked about acute. We talked about obtuse. A full circle. If I spin a full circle, I did a 360. Okay, full circle is 360. And now the last term. Trey, would you read that last little paragraph there?
If you put, when two angles share a side and a vertex, and they don't overlap, we call them adjacent angles.
All right, so if they share a side, for instance, angle A and angle B there, they share this side. They're next to each other. Those are called adjacent angles. Okay, those are called adjacent. So know that term as well. You're going to see that term here throughout the unit. Now, if I am writing down, let's say A is 115, and I say, what is angle B? What would you tell me? I'll tell you that this line is straight. That should trigger something in your mind about what those should add up to. Parker, what should they add up to if this is a straight line? They should add up to 180. So then you should be able to figure out what B is.
65.
65. How'd you get that?
180 minus 115.
180 minus 115. Okay, they have to add up to 180. They have to add up to 180. Questions on any of those terms? All right, let's take a look at today's assignment. Okay, question number 1, I'm assuming you can answer. You need to draw it. Answer how many degrees it is. Okay, question number 2. It's talking about an equilateral triangle. That's these green ones that we had up here. I think you can answer it based on what we know about equilateral triangles. And it does remind us that each angle is 60 degrees. Question number 3, asking us the same thing about hexagons and a square. And just to show you that that's actually the shape you will get. Why is that not fitting together like that? Are those hexagons?
Those are
Oh, octagons. No wonder. I don't have octagons. That one does not fit. Okay. Keep in mind, you know what the squares are all 90, and then we'd have to figure out what the other ones are. I'm curious to see if you can get that one. Question number 4, write a question. It gives us an equation. You need to write a question about that based on this information. Gives you kind of some hints there. Question number 5, distributive property. And put a big arrow on that one. It does go on to the next page. Let's pick one of those 4 to do. A, B, C, or D.
D.
D? Okay, let's do letter D. Had this on your quiz. Had this on your test. How do we do distributive property? Leerud, what do we got to do? Remember?
I do. Negative 15.
What do we do when there's a number outside the parentheses?
You have to do 4/5 to everything.
Yeah, times everything. So what is 4/5 times 10?
45th.
40 divided by 5. 8. And again, you could cross cancel there so you don't have to reduce. 4 times 2 is 8. Missing anything else with that?
And then you have to do
The y. Okay, next one. 4/5 times negative x. Negative 4/5 x. And 4/5 times negative 15. So I know it's going to be negative because I'm taking a positive times a negative. What is 4/5 times 15? Jada? 12 is correct. Always reduce. Okay? And again, that's what you're doing for all these. Watch the signs. Watch the signs. Question number 6. Last one. Cameron, would you read that one, please?
When puppy is gaining weight at a rate of 0.125 pounds per day, describe the weight gain in days.
Okay. So how many days would it take to gain a pound is what it's asking you. This is how much it gains every day in weight, the new puppy. How many days would it take to gain a pound? That's what it's asking you there. Okay, so 1 through 6, that is due tomorrow. Quite a bit of time today to work. Please work quietly. Let me know if you have any questions.